Today's A+ question is, find the density of a cubic centimeter of gold that weighs 19.3 grams, and we want our answer to be in the units kilograms per cubic meter. So let's get started. First of all, we're going to identify the formula that we need to use, and that formula, which we've learned is density, is mass over volume. We know the mass. The mass for it is always going to be how much something weighs in this particular case, and so we have the mass is 19.3 grams. We are also given the volume. Volume is how much space something takes up, and in this case the volume is 1 cubic centimeter. So when we plug these into our formula, we're just going to take the 19.3 grams and we're going to divide it by 1 cubic centimeter. Now, of course, it's not done yet. We have to convert these units into the unit we're being asked to find. So let's start with the mass first. We have to convert grams to kilograms, and I know that there are 1,000 grams for every 1 kilogram. Now I could use this conversion rate, or I can use its reciprocal, and that would be 1,000 grams on bottom per 1 kilogram on the top. Now, since I have grams on the top in my equation, I want grams to be on bottom in my conversion rate. So I'm going to use this second option over here. It's going to be times 1 kilogram per 1,000 grams. Next, we're going to work with the volume. This one's a little bit trickier because we have to convert cubic centimeters into cubic meters. Now we know, for example, that there are 100 centimeters for every meter, but it's not quite as straightforward to just say there's 100 cubic centimeters in 1 cubic meter, because that's not true. First, let's visualize, and then I'll show you how to calculate this. If we had a cubic meter, that's a cube that is 1 meter length on for the length, width, and height, that 1 cubic meter would also be able to be written as 100 centimeters in length, 100 centimeters in height, width, and 100 centimeters in height. In order to find the volume in cubic centimeters, you'd actually take 100 times 100 times 100, or you could say 100 cubed. The other way that we could look at that is we could say that if there's 100 centimeters for every 1 meter, if we're going to talk about cubic centimeters and cubic meters, we have to cube everything. So we would take the 100 cubed cubic centimeters. It's going to be equal to 1 cubed cubic meter. And so if we simplified this, we would have 100 cubed, and that is going to be equal to 1 million. 1 million cubic centimeters is 1, because 1 cubed is 1 cubic meter. Now we can use that information to find our conversion rate. So our conversion rate is either going to be 1 million cubic centimeters per 1 cubic meter, or the reciprocal of that, 1 cubic meter for every 1 million cubic centimeter. We look back at our original question and we have cubic centimeters on the bottom, so we're going to want cubic centimeters up on top in order for it to cancel out. So we're going to use this one. We'll multiply this one by 1 million cubic centimeters per 1 cubic meter. And we'll go ahead and keep multiplying out. So first thing we want to do is check our units to make sure they canceled correctly. So we have grams on top canceling with grams on bottom. We have cubic centimeters on bottom, canceling with cubic centimeters on top, and what we're left with is kilograms per cubic meter, which is what we were asked to find. Now we have our numbers, 19.3 grams times, we can just eliminate the 1 because multiplying by 1 does not affect the value, times 1 million over, and again we have 1 times 1,000 times 1, which is just 1,000, and this is going to be kilograms per cubic meter. This actually, we can do a little bit more canceling out. 1 million divided by 1,000 is going to take away 3 of those place value zeros in there, so our final answer is going to be 19.3 times 1,000 kilograms per cubic meter. And so as we calculate that out, 19.3 times 1,000, just move that decimal point 1, 2, 3 places, and it's 19,300 kilograms per cubic meter. And there you go. That is your A+ question of the day.